Ladies and gentlemen, on behalf of the VDMA and the organizers of the Embedded World Show, it is my pleasure to welcome you to this panel discussion about embedded vision, which is one of the most exciting topics right now in the vision industry. So thank you for being here. The topic is migration from PC to embedded and from embedded to vision. And I'm looking forward to hearing what the experts will say about today's status of embedded vision and the potentials ahead. First of all, let me introduce the panelists. To my left, I welcome Amir Sherman, who is Director of Engineering and Solutions of Embedded Technology in Europe, Middle East and Africa at Aero Central Europe. Next to him, we have Jeff Beer, founder of the Embedded Vision Alliance and president of BDTI. Next to him, Dr. Olaf Munkelt, Managing Director of MVTech Software GmbH. Arne Barke is next to him, Chief Marketing Officer at Basler. And to your very right, we have Leon Farasati, Director of Product Management Snapdragon Embedded Computing at Qualcomm Technologies. So thanks for being here. My name is Peter Stiefenhofer. I'm the founder of PS Marcom Services, a PR agency with focus on vision technology. I am very excited to hear the expert views about embedded vision, what's going on there, about latest developments, and I'm sure this will be a very interesting hour of discussion. My first question should really help you to understand what these guys are doing and how they are connected with embedded vision. So may I ask you to really give a brief introduction of yourself and how you are connected to the embedded vision technology. And Amir, if you want to start first.
Yes, so thank you very much. My name is Amir Sherman. I'm the Embedded Director in Aero Electronics, managing our backend engineering solution center. We have 40 engineers doing technical support, software development, and we are building boards. 3 years ago, we have started our system on module journey. So embedded system on modules, then we went to embedded boards, and the one thing that was missing, that is embedded vision. And we work together with our partners to connect everything together because this is what the market wants. So we have our cooperation with Qualcomm where we announced our successful cooperation having mobile phone processors to become embedded, connected with our Aero Qualcomm Dragonboat solution. And we just did a huge announcement this embedded world also about A20 that Leon will talk a little bit more. And this type of embedded processors needing vision, so we cooperate with Basler and we created our platforms. And we have boards now with embedded vision as a solution because customers want fast time to market and they want to get it now working with the latest technology.
We go to the technology a little later. Jeff, I guess everybody knows you in the embedded vision industry, but there are auditors that might not know you, so...
Thank you, Peter. Good morning. My name is Jeff Beer, founder of the Embedded Vision Alliance. The Embedded Vision Alliance is an industry partnership, about 75 companies, working to inspire and empower all kinds of system and application developers to incorporate vision into their systems, to enable systems and devices that are more intelligent, more autonomous, safer, and easier to use. We do this mainly by providing practical technical know-how to product developers, including many who are not computer vision specialists, but want to learn how to practically incorporate computer vision into their products. And we also work to help the supplier companies who are providing the key enabling technologies, the processors, boards, sensors, and so on, to connect with customers and partners and get good insights into where this technology is going and how the markets are developing.
Dr. Munkelt, how is MVTech connected to the embedded vision world?
Yes, good morning. My name is Olaf Munkelt. I'm from MVTech. We do only software, so we are the software guys since more than 20 years. And since more than 15 years, we do software also on embedded, so embedded vision devices, what is called today. So we have rich experience in bringing software on embedded devices, platforms, and run it. And what we see in the last 5 years, the interest in embedded devices is picking up rapidly. So it's really increasing. That's also why we think embedded vision has more than industrial applications. It also has a lot of applications outside the classical factory floor.
Arndt Barker is from Basler. So what is the connection of Basler to embedded vision?
Yeah, my name is Arndt Barker. I'm in the board of Basler. We are doing industrial cameras, so we are the camera guys. We provide the eye to the systems. And we have been approached by customers saying we would like to use vision also for embedded applications. So we saw a lack of vision modules. So instead of having cameras, you really need a vision module which nicely connects to these processing boards. And this is what we're focusing on since a couple of years. I'm really excited about the embedded market, what kind of opportunities this brings to us. We see many applications outside the factory. We truly believe that vision is just now entering new application areas outside the factory, and this is what we're heavily engaging with.
All right, so I'm in product management at Qualcomm. We're the processor guys. You know, and I look at this show and kind of, for me, has been a indicator of kind of our program and what we've done in the past few years. When we first came here, I don't think a lot of people had heard of Qualcomm. We obviously were in your phone and as a processor, but as a embedded processor, we had never been in this space. We've learned a lot about this about embedded from this show. So I thank you all who've talked to us in the past few years. And when it comes to vision, obviously in this panel, I'm the least knowledgeable guy about vision. But we have looked at the bringing the processing power to this vision market or to this embedded vision market. And as a consumer of embedded vision, whether it's a VR headset or whether it's a security camera in my home, I think some of the processing power that we're bringing in is going to be really exciting. It's going to really change, analytics on these devices. It's going to change what you send to the cloud. So I think it's really exciting, and the amount of investment that we put into, I think Amir mentioned the amount of investment we put into mobile. In terms of, obviously everybody wants a better camera on their phone. So Qualcomm, that's one of the areas where we're putting a lot of effort on obviously the camera processor, but the CPU, the GPU, everything that's in that SoC. So I think it's really going to be exciting. We came up with our latest processor, Snapdragon 820E, through Aero Electronics. And of course, there was an announcement with Basler that their line of industrial cameras is now supported on Snapdragon, which I think is a big deal. Because before, you were stuck with mobile sensors if you wanted to do an embedded device. So a lot is changing. I'll be happy to talk about it in the rest of the panel. But thanks for having me.
Thank you very much. So for those of you who don't know, we had a discussion on embedded vision almost a year ago on the same place. And some of the guys have already been part of the discussion last year. So my first question is, what would you say, if you're looking back the last year, what have been the main changes compared to the status we had last year to today? Jeff?
I would say that the two main changes I've seen in the last year are, number one, there's a huge growth in awareness among embedded system developers that vision is a practical technology, they can use, and why they would want to do so for autonomy, for ease of use, and so on. And number two, there's an important raising of level of abstraction in terms of development tools so that it's increasingly feasible to incorporate this kind of visual intelligence into systems without necessarily having to understand all the details of the algorithms and the processors and so on. And these are two critical factors to enable vision to become a mainstream technology as opposed to a niche technology that only a few specialists can use.
Does it work? Okay. So I think last time we spoke about that, why don't more people use vision? Because it's such a powerful technology for many applications. And we concluded that it's not so easy. So not many people are really capable of doing that. And this is partially due to high development effort bringing these technologies together. So I think what's really crucial and what changed within the last years that key companies forming partnerships in order to make sure that products are compatible, so it gets much easier for the customer to actually use these technologies in real-world applications.
And if I add one more point, what has changed from my point of view is if you walk the show this year, you see much more applications related to vision than last year. So the interest has grown, and the show always shows new things, which will probably become a commodity in 2 or 3 years. And in that respect, we have done the first step towards making things easier, making deployment of embedded vision solutions easier.
Okay, so there were critical voices that said the PC power is needed really to solve solutions in the machine vision industry. Nowadays, with all the improvements in the processors, in the cameras and everything, that seems to be changing a little bit. So would you say that there are more options for people using embedded vision now with the processors and everything speeding up and getting faster? Is that a question for Qualcomm?
Sure, I think everyone is looking at me. You know, I actually come, so myself, I come from the PC world. So I used to be at, you know, probably the most famous GPU company in the world on the PC side. And, you know, I was always kind of the guy who saw what's the next powerful GPU is going to do, you know, what kind of games we're going to be able to play, what kind of resolutions we're going to be able to render. And when I first came to mobile, obviously we were nowhere close to that. But as I look at everything that has come out in the last, I'd say about 7 or 8 years that I've been at Qualcomm, you'll be amazed at what the, you know, what type of GPU and what type of graphics power we now have in these mobile devices. So, I mean, obviously I'm biased on, you know, on our processor, but you look at across the industry, and you know the amount of investment that has gone into mobile is phenomenal. And one of the things we found was initially when we were talking about mobile, everybody was saying, look, you know, you need PC performance or you need PC experience. Nowadays, wherever I go, we talk about how PCs are trying to have the mobile experience, right? Everybody's like, yeah, you know, I'm looking for the mobile experience on this embedded device. So I think from the power and from the performance perspective, you know, we have made leaps and bounds. One of the things that I think kind of continuing on the last question was before it was really difficult for the embedded market to use our mobile SoCs. And I think that has changed. We have, you know, makers now using our processor. We have, you know, just regular hobbyist startups using our processor. So my goal and my role at Qualcomm is to really make it accessible, really put this hardware in the hands of people who are actually doing this type of work and creating these applications. So I don't think you need the PC power anymore. I think we're even beyond that. You know, really for us is how do we make it easier and easier for people to access, to harness what's inside this SoC. And it's not just the CPU, it's not just the GPU. There's a DSP, there's you know, a camera processor. A lot of things packed into one little SoC. So that's what I would say. Yeah.
If I can just build on that slightly, I think it's true that many computer vision, embedded vision applications require tremendous processing power, but more and more that processing power does not come from the CPU. It comes from an array of more specialized processing engines that are typically integrated onto the SoC. People for a long time have been using GPUs for this. They've been using DSPs, they've been using FPGAs, and in the last few years there's been a new generation of processors specialized for computer vision and machine learning algorithms. When you look at the aggregate performance of these chips, it's tremendous, and the performance provided by the CPUs is a kind of small thing off to the side. Most of the processing power, and especially most of the energy efficient processing power that allows us to run these algorithms in these systems without requiring a lot of cooling, comes from other processing engines other than the CPU. So as Leon said, we are in fact already way beyond the PC. When we talk about PC, we think about the CPU performance. But when we talk about these embedded systems, typically the bulk of the performance is not coming from the CPU, and it's much higher than what does come from the CPU.
Yeah, I wanted to say the same thing. So I think at some point when we looked at processors, the development of processors was mainly measured in speed and performance. And at some point this came to an end and we saw kind of a parallelism of processing, like you said. So we now have the processor, we have the DSP, we have the GPU for the camera, we have the ISP. You really need to look at all these resources in the processor in order to judge the power of such a device. And I agree, this is already way beyond PC power.
So we're already in the discussion about the applications or typical applications for embedded vision. So are there any other examples or special examples for the use of embedded vision where you say this really exactly shows the strength and the power of these of embedded vision technology?
Yeah, so we have one big customer in Germany that wanted to replace the normal PIR, all type of technology PIRs to vision PIRs. And what they did, it was really funny because they really started with, as I said, it was an engineer came to an affair, took a Dragonboat, play with it, start to connect cameras, and it was USB camera, and he looked for embedded one. So we connected, and we already put the Basler camera inside of it. And what they're doing, they're just replacing PIRs to vision, and then you can have all sophisticated security outside indoor application and outdoor application working with vision and not with the normal PIRs. And then you can get all the information on your mobile phone when you're out. And this is something that we are seeing a growing market on security.
So security is one part. Other options?
We see several application areas outside the factory. So we see a strong increase in retail application, which is everything around the shop. So you want to recognize people coming in and then customize your offerings to these people, similar like Amazon offers on in the internet. You want to have the same experience in the shops. Then automatic checkout, or whenever ever you saw the Amazon Go example where vision is used also for the concept of these shops. What we see with these applications is that companies providing solutions that are really specific. So you have one company doing people counting, another one focusing on checkout. So it's really application-specific solution because, as I think you pointed out, the market behind that is big enough. So we see many companies working on these verticals. And other big areas we see around smart city, smart building, where we also see kind of a lot of applications around that.
I'm sure you have many more examples, Jeff.
I would say one of the most exciting application areas is autonomous things. Not just autonomous cars, but all kinds of autonomous things. If you look at the evolution of biological creatures, vision evolved with mobility. When a plant is anchored in the ground, it has very little use for vision. But once an animal becomes mobile, vision becomes very important, so that the animal can find prey and avoid becoming prey and so on. And now we see that just about everything that moves in terms of devices that we make can really benefit from vision. And one great example of this is the vacuum cleaning robots that people have in their homes. You look at the previous generation and the current generation, it's a huge difference in their capabilities because of vision, including in some surprising ways, such as being able to clean more floor area per battery charge, because the device knows the floor plan of the room and knows where it's located. So instead of kind of wandering around at random and hoping that eventually every spot on the floor gets covered, it can actually plot an optimal path so that every spot on the floor gets covered with the minimum distance traveled. So it completely changes how those devices use their energy for cleaning.
Very interesting.
So I have to give shout out to two of my favorites. Of course, you all know about VR and AR, so I'm not going to do that. But very early on, we actually had a company who was in the medical imaging space. And what they were working on was, ultrasound devices. So, you're pregnant, you do the ultrasound. Obviously, that machine is very prohibitive. Oh, sorry. That machine is very prohibitive in remote areas and all that. So they made a portable ultrasound. So it's a little wand and connected to like a tablet-like device. It does analytics on that image and sends it back to the doctor who's sitting in the hospital. So that's on the human side. The other one, which I find hilarious, but I think is a great application, is this company who does a pig weighing devices. So basically, they have a whole bunch of pigs, and rather than putting them on a scale one by one, they're actually weighing them by imagery. So they have an algorithm. The pigs are just running, and they know exactly how many pigs they have and how much each one of them weighs. I think you look at across this industry, there's just so many ways that people are using this technology. I could go on, but I thought I'd give a shout out to the pig weighing guys.
Do you have that demo in your booth?
We should.
I'm going to come see that one.
Next year, okay? I'm bringing a live pig.
Yeah, maybe one more. A medical application, for example, you might know about people having hip problems, and it's normally in order to make a diagnosis on the hip problem, you need an X-ray. So not everybody wants X-rays very often. Another way to diagnose that is you simply analyze the movement of a person. So kind of a software analyzing the movement of a person very easily can distinguish healthy movement from unhealthy movement. So you simply need a video from the patient and you can tell whether he has a hip problem, what kind of hip problem. So a very, very easy diagnosis for a customer, much less cost, very effective also for doctors.
Mr. Munkel, any application examples from your side?
You mean from the embedded side, right? So apart from pigs.
You're not counting pigs, no?
Yeah, there are so many. One example is from the medical areas where for dentists, people want to get certain parameters of your teeth in order to make corrections, sometimes mechanically corrections. They are not so nice for you guys. It hurts. Sometimes only color correction, this is okay. And for all this, they need visual systems. And the interesting part about this application is that this is a mixture between embedded devices, which they have, and applications on smartphones, which they need to show the results to the patient in order to get comments or feedback and also to communicate with the manufacturer of these devices. So actually, it's an ecosystem. And this is a kind of application which I like very much because it's a B2B application from our point of view, and it's scalable, and it's a long-term application because this customer's in the market since decades already and provides similar systems. So this is an evolution of an existing system which adds more vision capabilities. And I think this is what we will see in the future much more. Whenever you can add value to an existing, say, sensor-based system by using vision, this will be done because it's affordable. It's simply there. And the more we have this kind of pre-configured, off-the-shelf devices, the more it is an invitation to simply try it out and make a proof of concept.
We heard some examples from exciting applications like counting pigs and medical area and so on. In the automation industry right now, we have a big change. Some topics are smart factory, digital transformation on the factory floor and all that stuff. How do these developments influence the machine vision industry and also the embedded vision part of that industry?
Well, compared to some of my colleagues here, I probably know a lot less about industrial applications. But one thing I'll say is that I think it creates an enormous opportunity where instead of vision being a kind of distinct stage in the manufacturing process, vision now starts to become integrated into every stage of the manufacturing process. For example, more and more we want to have collaborative robots that can work safely side by side with people instead of being fenced off in a cage. Well, for a robot to work safely side by side with a person, it has to be extremely aware of the people around it, and vision is a key part of how that happens.
Yeah, when we talk about smart factory, it's also IoT or Industry 4.0. It's about connected devices. Now, I think one colleague told earlier that you don't want to connect a camera direct into your network because it creates so much data. Nobody wants to have that in the network nor in the cloud. So for vision, it calls for computing on the edge. So you have your edge device, the vision goes in, is processed and then connected. In the current architecture, what we're seeing is that vision is normally part of a machine. So the vision portion is normally not connected to the network, but it's connected to the machine is connected to the network. With Industry 4.0, we will see more of vision processing on the edge, which is directly connected, and you can get access to the data from cloud solution. So we see an increase of these types of applications.
Yeah, and just connected to what we said, that think that Snapdragon 820, was in the last generation that it's now of all of the mobile phone, and everything that we can get from horsepower from the mobile phone we have now on embedded. And we have some example for industrial application and robots where in the past it was PC oriented and it was less on power consumption. Now this is what we are getting more. So customers are taking the big power, everything what we are doing on the mobile to the industrial application, and we have this exactly customers asking for using that.
Well, let me add one more thing to that. Industrial is actually really interesting. So actually during the show, when we first talked to some of the guys who are doing industrial applications, they told me, hey, Leon, we love Snapdragon, but there's no way that we're going to use it. We can't use it. And one of the first things we heard was in industrial, there are expectations with respect to life, with longevity. So mobile is a very powerful platform, but you throw your mobile device out, on a year or maybe 2 years. I have mine, for a year and it's already old. So one of the things that we learned going after the industrial market is, obviously the design cycles are longer and the product life cycles are a lot longer. So we had to go back to our company, to Qualcomm, and say, look, we need a process where we could take these mobile SoCs and give them additional life. So that for us was obviously a big learning, a big change in business model, where we said, look, we're going to take 1, 2, maybe 3 of our processors, Snapdragon 820 being the latest one, and make them last longer, and be able to publicly commit to that extended life. So Snapdragon 820, we're committing for supply availability and support till 2025. And that required really fundamental changes internally for us to be able to put that process in place. And that was driven by the industrial market.
Maybe I can add to that. So you all know when the iPhone came out more than 10 years ago, and we have smart people on our customer side. There are a lot of engineers with funny and interesting ideas. And soon after the iPhone came out, people came back and said, this is really nice cameras in there. So why are you charging so much money for your industrial camera, whereas I get much more resolution here and it's less the cost? By the way, the processor is nice as well. Can I get that? So we've been asked these questions for at least 7, 8 years now. So I think slowly now the industry is responding to that, giving also customers in industrial or B2B applications access to this technology, which previously was only used in the smartphone.
You mentioned before that the eye is something that's very important to improve applications in any kind of industry, but there are also other technologies like sensors, like distance measurement sensors and all that stuff. Do you see that embedded vision as a market is growing faster, slower, at the same rate as other sensor technologies? Or is it hard to say because you're on embedded vision mainly?
So what I'll say is I believe it will grow much faster, and here's why. If you look at all of the variety of sensors that can be integrated into a system, vision is unique in that when you have an image sensor and a processor and algorithms, you essentially have a software-defined sensor. If I have, for example, video of a person's face, I can say who that person is, or if I don't know who they are, I can say their gender, their age, their emotional state, if they're tired, if they're intoxicated, their heart rate, all of this just from the video with the right algorithms. And there is no other type of sensor that has this set of diverse capabilities. As people want to create smarter, more capable systems, those systems need to understand more about their environments. And vision is extremely powerful to bring all kinds of information into these systems, much more so than any other class of sensors.
Well, I think I understand your question, like, do we have any experience like from last year to this year or so? I totally agree. The market potential is much larger than the traditional machine vision market, what the traditional machine vision market addresses. If I break this a little bit down and say, okay, last year the machine vision industry in Germany has increased by a little more than 15%, which is already a great result compared to other industries. Then I would say that even within the automation industry, where machine vision is part of, this is an excellent result. So the proximity sensor guys, they don't have this kind of, steep increase in growth. This is one point. The second point, I can only talk for my company from the software part. What we see is compared to our company growth last year, the embedded part has grown twice as much. And this is also due to the fact that we see applications outside the factory floor.
Maybe add to what Jeff said. So we clearly believe in the potential of vision compared to other sensor signals. I think another aspect is that if you deal with a temperature signal, it is much easier to solve that on a technical level. So people were much quicker to kind of offering solution on that. And vision is more difficult, so we believe it's totally underutilized, and if we can crack the nut of make that easily available to many more applications will start to use that.
Software seems to be a very important part of a system. So is today's software for embedded vision already what you need or what the user needs, or are there any improvements that have to be made to really make it easier for the user to use embedded vision? I think that's a question for you. Yeah.
Yeah. My view on this is that it's a diversity of products which you see, software products which you see. There's a habit in a large space of the community in the embedded vision area to use open software tools, which is fine and which is okay. The point is that everybody has to judge by himself what is the learning curve he has to go, what is the speed, how we can deploy a system. So I would better look from this perspective on this component software, which is also true for the software tools which we need in order to utilize the power of the CPUs. So time to market, I think, is important. We have learned that in the mobile section, time to market is everything, because if Samsung has released this phone with this camera, with this software tools in it to increase the resolution of the camera, then Apple has to do the same thing like half a year later. So in the industry, typically we have longer cycles, and we are also in the process of shorten these cycles, by the way. So time to market is really crucial, and for that perspective, software tools, of course, are of great help. What I want to add is the part of the machine vision, the traditional machine vision world, and the, say, embedded vision world with these many B2C applications, they are still kind of separated. So this is not one, they are not under one umbrella where they exchange standards and they have a smooth conversation topic. So they really need to get to know each other more in order to see what are the benefits from one side and from the other side.
There's some really great news about, when we talk about vision software, to a significant degree, we're talking about algorithms in software. And although the hardware has improved dramatically over the last 5 years to enable us to deploy vision in many new places, a key bottleneck has been creating the algorithms needed for a specific application. One famous company in the automotive safety space has said that they've invested approximately 1,000 man-years just in developing the algorithms to do a few things for automotive safety, like detect pedestrians and lane markings. Obviously, that is not scalable to thousands of applications. We have to make it much, much easier to develop the algorithms for the application. And the huge breakthrough that's enabling that is the rise of machine learning algorithms, where instead of engineers meticulously crafting exquisitely complex algorithms where they're trying to explain to the processor how to tell the difference between A, B, and C, now we have a much more general algorithm that learns through example. Imagine if you were trying to learn how to tell the difference between 100 varieties of dogs just by reading about them, not ever seeing a picture. That's essentially how we've been coming up with vision algorithms for the last 50 years. It's possible, but it's very slow and painful. Now with machine learning techniques, we say, forget about that. Instead, here I have 100,000 pictures labeled of different breeds of dogs. I'm going to show you them just like you would with a child. And remarkably, just as young children can, these algorithms learn extremely well how to differentiate these cases. To me, this is just a dramatic breakthrough. That's the key thing, along with the improvements in the hardware, that's enabling vision to really spread into tens of thousands of new applications.
So I would like to add on that. Think about it from embedded market. There is already a couple of years of Android application running with vision on it, but none of them was really embedded. So it's related to the mobile market. Now, having Qualcomm the same application in the mobile now becoming embedded. And I have example in my team in Gdansk in Poland where they're using already available apps that was designed for the mobile application, and now it can move to an embedded application, having a better camera from our partners, and exactly the same application can be used differently for the embedded market. And this is something that we are seeing more and more, using what already exists from the mobile to the embedded, and this is very important.
Can I add one more to that? I think our problem or our challenge from Qualcomm perspective is the software that goes underneath everything. So, a lot of people, I came up here, I said, we're the hardware guys, but most people don't know. Qualcomm has more software engineers than we do have hardware engineers, because it's a lot more complicated to create the software that actually runs all the hardware pieces that we put into Snapdragon. So our challenge has been, how do we bring this mobile software to the embedded space and make it as accessible and as open as possible? So, obviously we put a lot of investment into Linux, into kind of, we talked about open source, but you need to have access to the underlying cores that's inside Snapdragon. It cannot be behind the wall. So that is something that, for our team has really been important, is we enable the kind of the baseline, give access through the open source community, and a lot of good things are coming out of that. We talked about robotics, Open Source Robotics Foundation. They created the robotics operating system on top of Snapdragon, with, the access that now is available through the open source Linux. So for us, it's a challenge of how do we make it as accessible as possible, so these types of algorithms can be built on top of it.
Maybe to add to that, we talk about making machines see, and ideally you can have kind of the generic seeing software. I agree with Jeff, so deep learning maybe is a path forward. What we've seen in the past years is that these libraries have been accumulated of use cases. So there's one use case by the next, and this use case was solved by algorithms. And over collecting many, many cases, this is how these very nice libraries have been built. Now, these libraries have been built mainly for certain application use cases. If we now add many more outside the factory, there are many use cases which are totally not covered. So this is what we will see over the next years, that we start to accumulate these use cases and find a nice solution for each of these cases. And it's quite different. So in the factory, you want to inspect products, want to pick products. Now machines move kind of in space. So everything what you want to get from your own eyesight, these machines want to have. They don't want to run into walls. They don't want to run people over. They want to react to people standing in front of them and so forth. So nearly everything which you use your vision for, you can envision as a sub-function of this computer vision of the future.
So we heard there are a lot of improvements in software, a lot of improvements in hardware, in algorithms. But still, I remember from last year, the discussion said one big bottleneck is the knowledge of the users and the ones that should use the technology. So this is something I think the industry needs to improve, that the user gets more knowledge and knows and understands the technology to use it in the right way. What are your efforts to really get more knowledge to the user about the embedded vision technology?
So I think we've seen an exponential increase over the last couple of years. The Embedded Vision Alliance is one part of that, but many, many companies and organizations are working to do two things. One, as I mentioned earlier, to provide easier to use and more accessible tools and development boards and other resources. And secondly, to provide education to engineers so that you don't have to have a PhD in computer vision to effectively integrate computer vision capabilities into systems. So it's online training classes and it's conferences. An embedded vision track is added this year to the Embedded World Conference for the first time, for example, and all kinds of open source projects and example designs. The number of these things that are available has increased hugely over the last couple of years, and I think the number of engineers using them has also increased enormously.
Yeah, I think we have three parts. One part is education. Education, we do videos, which you can look online. We have created a special website where you can see application examples, which people can use and then rebuild on. And then the second factor is cooperation. So we try to cooperate with many partner companies on the stage here, and we exchange a lot of information. So when our people go out, they not only can talk about the processor or the camera or the software, but they can talk to a customer in a broader sense, and by this educating as well. And then we participate a lot in these shows trying to educate customers.
So for us, it's really easy, because I remember 3 years ago when we started to buy for a normal engineer a board having camera, 300, 500 euros. With the cooperation we have with Qualcomm, we have affordable $75 Snapdragon machine that you can buy or get from here, or depend on the application. And for us, the target is really, really easy. Just go to Aero, ask for the Snapdragon board, and you will get it. Because our target not to sell boards, our target to get designed based on the Snapdragon technology. And we are doing it in affordable price, or really just go and take it.
Okay.
Maybe I add to the Dragonboat platform, back to kind of giving that access. One of the things that we did with the Dragonboat when we first started with Aero is we purposefully picked up a open source standard. So it's called 96 boards. It's a standard that was created by Linaro, which is a Linux on ARM consortium. And what it does, it gives these predefined connectors on a open source standard that allows you to now put mezzanine cards on top of that platform. And I think that really, well, thank you, Amir, for demonstrating that. But the idea is that, as an end user, Now it's very easy for you. You pick up a development board and you can add a camera board on top. You can add a drone board on top. You can add a sensor card on top, or multiple ones. So I think that has changed the game. We see a lot of really nice projects coming out of this from universities, from hackathons, from online courses, because that platform is very accessible, and you have this fairly large ecosystem of these mezzanine cards that are growing. And I think the camera one, which thanks to our friends here in Basler, I think that's really going to now open the doors for this type of development.
So we covered a lot of topics about embedded vision. Are there any questions from the audience? Where are any needs from the users or anyone who says or has problems, questions, ideas for improvements for the embedded vision industry? You're all happy?
The first one will ask will get a Dragonboat free for me. So.
You have to use the microphone, please. Or take this one, yeah, it's fine.
Yeah, thank you for all this interesting information. I'm wondering when the new general data protection regulation is coming across in May, is there any impact in all these developments, and are there security aspects you want to let us know about it?
So that's an excellent question. I'm not an expert on the regulations, but here's what I see. When you are concerned with privacy, that argues for processing at the edge and limiting what data is stored and transmitted. A great example is in this sector that was mentioned earlier of the home security cameras. There's a company called NetAtmo that has such a camera that goes in your home. And one of the options you have when you configure that camera is to set the camera so that when a known person is in the scene, the video is not recorded or transmitted. So only when unknown people are in the scene, then is the video recorded and transmitted. If you have intelligence at the edge to understand who's there, then you have much more ability to control privacy versus just vacuuming all the data up to the cloud and then trying to figure out what to do with it.
Does this answer your question? A little bit.
Let me add to that. Security always comes up when we talk about our processor. Coming from the mobile space, obviously everybody has one in their pocket, and it's got to be the most secure device because it's with you all the time. So I think now bringing this processor into the embedded space, my hope is that brings all the security work that we've done on the mobile side to embedded and hopefully to embedded vision. So I see a lot of, synergies bringing, the work we've done with security for mobile, bringing that to embedded vision. And I think that was a great example. I still really love the company who did the baby monitor. I think, those types of applications where you're not sending data where it can be hacked or it can be, misused, and you just processing it at the edge before sending it out. I think that helps with security. But on top of that, all the protocols that need to be in place. I think, I see a lot of investment that we're putting in because it's critical for a mobile device to be secure.
So it's almost 12 o'clock now, so we have to finish this very interesting discussion. But I have one question for all of you as a final question. Imagine we are here next year, same time, same place, discussing embedded vision. What would you like most to have improved in that time, during that year?
Yeah, so from my perspective, having, Snapdragon 845 to be embedded can be something I will ask Qualcomm, but this is our stuff. But yeah, to just improve our software capabilities, we are doing more and more on that, having more linear, more code, more demos generated. This is our task to cooperate more together, having not 1 or 2 or 10, 20 of demos with a lot of the varieties.
So I would say that the technology has improved so much, so fast, the sensors, the processors, the software, the tools, that it's gotten a bit ahead of our imagination on how to use it. And I think that's the thing I'm looking for most improvement on now is a growth in awareness in system developers across all industries. What can we do if we can add, as Arndt said, human-like visual perception to our product? How could we make it better, safer, easier to use, more secure, more capable? Because we're at a stage with the technology where we are largely limited by what we can imagine that we can do.
I'm interested in technology, so I would love to see from 1 year from now processors, so to speak, which are able to process deep learning algorithms efficiently. You mentioned this earlier. This would be an own topic. I would have to say a lot about it because it's really a great technology. The problem is how to utilize it correctly or efficiently for many customers, because there are many applications where you don't have 10 million cats and dogs. And you don't want to recognize cats and dogs. You want to find defects from, say, a dozen images or so. Anyhow, it has really great opportunities, and I would wish that there would be support from the hardware side in order to, speed these things up. Not particular for a single application, but kind of general purpose.
We have two aspects. The one aspect, I think these vision applications are so complex, no single company can solve the problem alone. So one key is the cooperation amongst companies. So the better we can cooperate, the easier we'll get for customers. And the second thing is education. So I think the better the job we do in educating customers and the broader base of people willing and able to use it, the faster we can make progress.
Well, echo what Arndt said here. I think for me, personally, we unleashed the 820E just last week, along with the Basler cameras. I would wish to see maybe some new use cases, some new applications based on this platform. Maybe I have some new fun examples to talk about if I'm here next year. Maybe something not to do with pigs, but something fun. But I think, really it's all these things that we're putting together that I think is going to change the next phase of this. We talked about sensors. I think you got the imaging sensor. There's a lot of other sensor inputs that can come into play. So putting it all together and processing it at the same time, the area that personally I would love to see is, we talk about these VR headsets and augmented reality and, untethering it and just being able to even bring it to the industrial space. I would love to see something where, I'll be standing up here and, I can kind of see you all with, through another piece of information. So I think there's a lot that we can do with additional sensors on top of the imaging sensor. And I will look forward to that.
Thank you very much. This was the VDMA panel discussion, migration from PC to embedded and from embedded to vision. So many thanks to the panelists for their interesting statements. Many thanks to you as the audience. I hope you have heard a lot of interesting stuff and took interest in this discussion. For your information, the conclusion of what we discussed here will be written down in an article in the Computer and Automation magazine, one of the next issues, I think in April. And thank you again. Thank the VDMA for organizing this panel discussion, and have an exciting day at the Embedded World 2018. Thank you very much.